So hello people. Today we're gonna go through the material we covered in lecture 2, which are basically equations, and we're gonna talk about the linear equation, quadratic equation, exponential one, and logarithmic equation. Um, these topics are quite easy, so I will not waste much time of yours. We'll go like immediately to linear equations, which are like easiest possible ones. Um, As you see from here, they are always written in a form of y equals ax plus b. Most of the time, a, b, and y will be given, so the x is the constant that we're looking for. So here, like the example of the linear equation would be y equals minus 5x plus 4, and so on. Uh, since there's not that much to talk about this, there's nothing special, I'll just go through like quickly through the word problem and then just move to the other equation. So this is a word problem from the slide 2, and it's a word problem 1. So a company wants to know the total sales required to make a profit of 200,000 euros. The variable cost per unit is 12 euros and the total fixed costs are 450,000 euros. The unit selling price is 18 euros, and how many units do they have to sell? So our x in this case, and what we are looking for, are the units that they need to sell. So we will put x to the every single number where it says unit. So by looking here, you have unit of the variable cost, which is 12 euros, and we have unit for the selling price, which is 18. So my camera died, I'm sorry. So when we're approaching the linear equation, we're just going to write everything that we know and then solve for x in this case. So we know that when we are looking for profit, the general equation is selling price minus costs. So that's how we're gonna approach this exercise. So we're gonna write 18x, which is our selling price, minus 12x, which are our units of variable costs, minus 450,000, which are again our costs, and that would give us profit of 200,000. We would simplify this, so we would have 18 minus 12 is 6, so we're gonna have 6x here, minus 450,000 to be equal 200,000. When we plus these two, we will have 6x to be equal to 650,000, like this. And then we're just gonna solve for x. You just plug this into your calculator. 650,000 divided by 6 would give us a number of 108,333.333, so on. And the final step in solving the equation would be just to simply answer the question, which would be that company has to sell 108,333 units of the product in order to make a profit of 200,000 euros. Speaking of linear equations, I wouldn't add anything else. It's really straightforward. You just write everything you know from the question, then you just simplify, as long as you don't have a really simple equation, and then you just solve it by plugging it into the calculator, and then it will give you your answer. Good. I'm gonna move to the quadratic formula. Once again, it's really simple, it's really basic. I will not make a life story about it. There are a few things I wanna specifically talk about when it comes to quadratic formula, but these things we'll just like go through quickly. So the general formula, and how would you know that formula is a quadratic? Basically, the x would have the power of 2. So when you see the power of 2 being like the biggest power in your formula, you would know it's quadratic one, and you would find x, actually 2 x's, by plugging them into the formula for x. This will give you 2 possible answers, and then depending on your question and the exercise you're working on. You'll either choose both answers to be correct, or you're going to choose one. It depends on the question you're working on. I will not go through this example because from working with you guys, I know that there is nobody who didn't get the quadratic equation. But again, this document will be on Google Drive, so please take a look at it if there is a confusion. And there's one thing I actually do want to talk about when it comes to the quadratic equations and quadratic formulas, is the fact that that what we have under the square root, fourth root, sixth root, any root must be positive. So when you have your formula and when you put the numbers from your formula into this little equation over here, the number that's given under the square root must be positive in order for quadratic equation to be possible. So guys, if you actually remember that once I said that there was a typo in an exercise that we were provided during lecture, the reason for the typo that occurred there is because we had negative number under the square root, which is not possible. And why it's not possible, I want to take like 20 seconds just to like briefly explain this to you so that there are no confusions. And this is also important when it comes to logs, and I feel like we weren't nobody explained this to us. So you don't have to memorize this, this is just like for you to know. If we have square root of -9, we cannot, it is not correct, but also it is correct. Why is it not correct? Because there is no number timed by himself or herself that would give us negative number, right? But there is something that's called imaginary number, and the imaginary number is actually number that does not exist, but is number of is the square root of -1 or square root of any negative number. So if you ever see this little notation here, I, you would know what is it about. You would see, if you ever see like 3i, you would know, okay, that is square root of -9. So square root of -9 would give us 3 imaginary. And I think this is just important for you guys to know what it is. You will not use it, you will not be asked at exam, hopefully, and you don't need to memorize it. But just in case you ever see it, you will know it's imaginary number. And that's pretty much all I want to say about it. It's I'm saying it just for fun. I mean, it's fun for me, so I hope it will be fun for you as well. And now I will move to logarithmic and exponential equations. So these two equations usually go together. Depending what you're looking for in your form or formula, you would just shift between log and exponential form. And what do I mean by saying shift? So let's take a look at this particular logarithmic equation. So it's log of b, the power of a, to b equals to c. If we are looking for b, let's say that our b is our actually x, the number that we need to find, it would be impossible for us using non-programmable calculator to just like plug it like this and expect a straight answer. In that case, we would need to put it in the exponential form, where our b, or our x, as you wish, would be equals to the base to the power of c. So we would have a to the power of c to be equal b. And what I mean by that is we can take a look at this example. Let's say that we don't know that this number is 9. So log of x in the base of 3 would be equal to 2. So how would we find this x? Just base to the power of this 2. So 3 to the power of 2 would give us 9, which is our answer. So that would be pretty much of it. I wouldn't, once again, there's not that much that I can say about the exponential equations. They're really easy, they're really straightforward. There's nothing more than this. But however, there are some things I want to talk about when it comes to the logarithmic formulas and equations, and these are just 5 little points that I wanna make for you guys. So first of all, and something that you really need to be cautious about, careful about, is that log should never ever be negative number. And why is that? So let's take a look at this example. Log of negative 9 to the base of 3 to be equals to x. So the x is number that we need to find. And to simplify it and to put it into the exponential form, we would write 3 to the power of x to give us negative 9. And if you remember what I just said like 20 seconds ago, this would be actually the example of the imaginary number, the number that does not exist, because there is no number that you can put instead of this x to get negative 9 out of positive 3. So in that case, x does not exist, and therefore this logarithm is not possible. So please be cautious about that. Second point I want to make is that logs with the same bases on the different sides of the equations, equality sign, cross each other out. So what does it mean? Log of x plus 1 in the base of 5 to be equal to the log of 3 in the base of 5. So in order to find x and to solve for x, you would cross logs and bases out. You will stay with x plus 1 to be equal to 3, and then using some advanced math skills, you will figure out that x is 2. But please be careful. This applies only when logs have same bases and are on the different sides of the equality sign, which means that sign equal, logs different, same bases, and that's it. Another thing that I want to point out, especially because we're dealing with non-programmable calculators, when we have number e in the base of our log, we would use the natural logarithm, or so-called ln, to calculate it. So in order to avoid having e in a base, we would just write ln and then everything that we had in the parentheses, like I wrote x here, but it can be any number. The answer will be same, okay, as if you put log in the base of e, but since we are doing with non-programmable calculators, it will be way easier. One more thing I want to emphasize is when we have a log but there's no base, we would assume that that on the position of base there's number 10. That's really important, especially if we need to find this x. So if I had log of x plus 1 to be equal to 20, we need to find that x, but we don't have base given. In that case, base is always 10. And you can check that as well, it's correct. So if you don't believe me, put it in calculator. And lastly, there was a question last time when I met with you. Somebody asked me, like, how do we put bases in the non-programmable calculator? So if we have log of 5 and the base of 3, in non-programmable calculators, we would write log of 5 divided by log of 3. And that's it. That would give us the correct answer. Good. That's it from me for lecture 2. I think this was really easy. I hope you find it easy. Please, if there are any questions, call me. I will work on the video for lecture 3, and hopefully we'll be done with it soon. So see you people. Have a good night.